Hello, fourth grade. Welcome back to class. Today we're going to be talking about more division and multiplication concepts. We are going to check page 30 and continue on to page 31. So I just wanted to bring your attention to some things that we did last time. These are a couple of activities that you could do to practice division with things that you have at home, like stones or cards. Here is a link to a shared drive that you can use if you're interested in practicing more concepts around multiplication and division. And this link will be in the video description below. So go ahead and check or click it in the video description below. There's lots of different activities that you can play to practice division a little bit more. So if you have any questions, you can let Mr. Joseph know. Otherwise, there's also this game. This is a really fun game to practice division, and you will be able to advance in your division knowledge. So on page 30, boys and girls, we were doing some practice problems with multiplication and division. So check your answers if you didn't get those. Pause the video and check to make sure that you did them correctly. We were also working with the long division concept. If you didn't understand that concept last time, I would encourage you to go and click on the link in the video below to understand the concept from last class. Okay? And if you really want to, you can fill in the boxes from the answers below on page 30, but that's optional. Let's go to page 31 and continue with the new concept for today. The concept for today is division of one-digit numbers by 10. So let's get started. This concept, boys and girls, is a very important concept, and it's actually building off of what we've done in the past. Okay? When we divide a number, for example, 8 divided by 1, we're just telling ourselves that 8 is easily divisible by 1. It's just itself, right? It's just 8. If we do another problem, for example, 55 divided by 1 just equals 55, right? Any number divided by 1 is itself, okay? Even 0 divided by 1 is itself. So let's continue and do a couple of problems on this page, page 31, okay? On page 31, it says divide by 10. We're going to be dividing by 10 with all of these numbers. Now, when we divide by 10, we are basically trying to find if our decimal point moves over, and it's going to be moving over every single time, okay? It's going to be moving over to the left and making the number smaller. So, when I divide by 10, I can simplify the problem, right? Simplify. Okay? Making the problem more simple to understand is a very important concept, okay? So when I simplify this, I'm going to divide both sides by 10. And my new problem is 8 divided by 1, which just equals 8. You'll notice I divided 80 by 10, and I divided 10 by 10. You have to divide both sides by 10. Let's do the same thing in letter B. All right? Letter B says 800 divided by 10. Well, I'm going to divide 10 by 10 and divide 800 by 10. That's going to simplify both numbers. And my new problem is 80 divided by 1, which just equals 80. All right, let's do the next problem. The next problem says 8,000 divided by 10. Now, 8,000 divided by 10 is dividing both sides by 10. And our problem simplifies to 800 divided by 1, which just equals 800. All right, this next problem, letter D, I actually wrote incorrectly. There should be an 8 right there. Let me just change that quickly. Should be an 8 right here. This is an 8. Okay, let me see if I can change that here on the screen. Actually, that makes more sense. Here, let's change that right here on the screen. This is an 8. So there we go. Okay. So when we're looking at these types of problems, boys and girls, we need to understand that both sides need to be represented, okay? So we're going to divide both sides by the same exact number, 10, and our new number that's left over is 888. Okay, check your answers to make sure that they're correct, and we'll go to the next part of problem, page 31. All right, so let's go to the next problems. Letter E, same concept. What I'd like you to do is pause the video, and I'd like you to do these problems on your own to see if you understand them. All right, hopefully you pause the video and we are ready to continue with these problems, okay? So this next problem is the same thing. We're going to divide both sides by 10, and our new problem is 543 divided by 1, which just equals 543. Okay, letter F says 7,080 divided by 10. We're going to divide both sides by 10. In other words, we're going to move the decimal point over one spot to the left. And our new problem is 708 divided by 1, which just equals 708. All right, let's do the next problem. The next problem says 8,100. Well, 8,100 divided by 10 is the same thing as 810 divided by 1, which just equals 810. And the last problem is the same concept. 6,300 divided by 10 is the same thing as 630 divided by 1, which equals 630. All right, those are pretty simple problems. Hopefully you understood that. What we're going to do now is we're going to do a different concept, okay? This concept is division, but it's also estimation. So if you have not understood the process of estimation, I would recommend that you go back to page 27 to understand the concept of estimation a little bit better, okay? So let's continue with the next problem. On page 31 on the bottom, we are dividing. 2,475 divided by 5. Well, to estimate this problem, we can ask, is 2,475 closer to 2,000, 2,500, or maybe 3,000? Again, an estimation is just a guess or an approximation to come close to the number. So, which number is closest? Well, if you really look at it, this 4 has been told by the 7 to move up. So our closest number is 2,500. I'm going to put that in the first blank. All right, I'm going to transfer my 5 over to my problem. I'm going to transfer that over. Okay, and now I have 2,500 divided by 5. Well, I know that 25 divided by 5 equals 5. So that's going to be my base number. That 5 is going to be my base number, which I'm going to put in my problem. But I also need to look very closely at how many zeros are in my problem, right? We have 1, 2 zeros in my problem. That means I'm also going to put 2 zeros in my answer. So these 2 zeros, which I have in my problem, are going to also be in my answer, okay? In other words, 2,500 divided by 5 equals 500. Or you could say that 5 times 500 equals 2,500. All right, the book wants you to multiply as well, but we're not going to do that step. We're just going to estimate and divide. Okay? All right, let's continue. 4,214. What is that estimated out? Well, I know that 4,214 comes close to 4,000. It comes close to 4,200. It also comes kind of close to 5,000. What's maybe the closest? Let's round it to the nearest hundred. Okay, I think 4,200 is probably our best option. So I'm going to put 4,200 right here. That's our estimate. Okay, and transfer my 7 into my problem. I have a question for you. 42 divided by 7 equals what? Well, if I know that 6 times 7 equals 42, I know that 42 divided by 7 equals 6, which means that I can put 6 in my answer blank because that's my base number. 42 divided by 7 equals 6. But how many zeros do I have in my problem? We're still dividing, right? It's not just 6. We're dividing by a base of 100. I see 1, 2 zeros, so I'm going to put 2 zeros in my answer. In other words, 4,200 divided by 7 equals 600. Or 600 times 7 equals 4,200. All right, good. We're going to go to letter C. I would like you to pause the video, and I would like you to try letter C on your own. Okay, remember that you're going to, just like the other problems, you're going to estimate first, and then you're going to divide. All right, hopefully you paused the video and you checked out that last problem. You did that on your own. If you didn't pause the video, I'd like you to pause the video and try that last problem on your own. 6,480 can be estimated in many different ways. We could estimate it to the nearest 1,000, the nearest 100, the nearest 10. I think I'm going to estimate this to the nearest 10. So in other words, this 8 is going to tell this 4 to go up. Okay, so my estimation is going to be 6,500. Now we could also do it in a different way. We could maybe look at the multiplication tables. So if I look at the multiplication tables of 9, right, of 9, I can say 9, 18, 27, 36, 45, 54, 63, and so on. When I look at my tables of multiplication, I notice that 63 goes into 9 7 times. Therefore, I think I'm going to pick a number, my estimation, that has 63 as my base. So we could say that 6,300 is an estimation. Okay? So 6,480 is now estimated as 6,300 divided by 9. Well, if I know that 63 divided by 9 equals 7, I'm going to put my 7 in my answer blank. But we're still not finished. We need to count to see how many zeros are in our problem. I count 2. That means 2 zeros are going to be in our answer. In other words, 6,300 divided by 9 equals 700. Or approximately 6,480 divided by 9 is approximately 700. Let's check that on the calculator to see if that's correct. I'm going to bring my calculator here and just check that to see if it's correct, okay? It says 6,480 divided by 9 equals 720, which is exactly, it's very close to 700, okay? Let's do the other one. Letter B, 4,214, divided by 7 equals 602. Yep, 602 is very close to 600. All right, good job, boys and girls. What we're going to do now is erase everything and go on to page 33. So we're going to skip page 32. Okay, I want you to skip that page. You can even put, maybe if you want to, you can put an X on it. You can strike through that page if you want to. You can strike through it. We're not going to do page 32. We're going to do page 33. Okay? This concept is also review. You've learned this in Máximo, in Español, right? So we're going to continue with multiplying, but understanding that there is an easier way to do some of these multiplication problems, okay? So 6 times 2 is obviously 12. Carry my 1. 2 times 2 is 4, plus 1 is 5. But here's the kicker. Here's the interesting part. I know that these two problems are very similar. 26 times 2 is very similar to 26 times 20. Therefore, I'm going to put 52 in my answer blank as my base number. But I cannot forget to also include the 0. We are multiplying by a base 10, which means that we can put our 0 directly into our problem without having to multiply again. 520 is my answer. Do you see the difference between this number and this number because of that 0? Let's do one more problem. If we look at 54 times 2, I can multiply like normal, right? 2 times 4 is 8, and 2 times 5 is 10. 108 is my answer. But if I look at these two problems, boys and girls, I can recognize that there is a pattern, right? 54 times 2 is very similar to 54 times 20. The only thing is we are multiplying by a base 10 in the second one instead of just a whole number, a one-digit number. So I'm going to put my base number in my answer blank, 108, and I'm going to include my 0 in my problem because we're multiplying again by a base 10. We're actually multiplying this by a factor of 10. So since we're multiplying by a factor of 10, we're going to include that 0 in our answer. Do you see the similarities between these two answers and these two problems? All right, we're going to do just 4 more problems on this same page. But what I would like you to do is pause the video and try to do these problems on your own. Okay, hopefully you paused the video and you did these problems on your own. We're going to check our answers to make sure that they're correct. 8 times 3 is a normal multiplication problem. It's 24. Carry our 2. 6 times 3 is 18, plus 2 is 20. So 204 is our answer. Since these two problems are very similar, I'm going to just replicate my answer into the next problem, 204. But I notice that there is a very important number right here because we are multiplying by a base 10. Okay, we're multiplying that by another base 10. Unlike this one, we're not multiplying by a base 10. We are only doing it in this one. So that extra 0 needs to be represented inside of our answer. All right, good. Last problems, boys and girls. 40 times 5, well, 5 times 4 is 20, so just 200, right? I just did that in my head. We don't need to do the whole thing, right? And for 40 times 50 is very similar. Okay, these two problems are very similar. 200 is going to be my base problem, but there's one thing that's different between this problem and this problem, and that's that 0. And that's because, just like I said before, we are multiplying by another factor of 10, which means that we need to include that 0 in our answer. Hopefully you see the difference and similarities between these problems. These are some math tricks that will help you gain understanding of math a little bit more. So thank you very much, boys and girls. We will continue with the problems on the next part of the page next time. Okay, we'll do this time, next week. So hopefully you are ready and you have a great week. We will talk to you soon.